Hi, this is Swathi Jasti. I work as a senior data app specialist with Snowflake. Today, I'll go through the Tasty Bytes driver app that I've developed and show you the features of the app, and also go through the code and explain how easy and performant it is to create a data app using Snowflake. Just to give overview on what Tasty Bytes is a large food truck network which includes multiple brands. Its mission is to become the largest food truck network in the world with sustainable profits and also reducing food waste. In this demo, you would see how Snowflake is helping Tasty Bytes organization to achieve their goals. As part of the demo, you'll see how Snowflake is helping create and deploy location recommendation, inventory forecast machine learning models to reduce food waste and increase profits. Price elasticity model will also be deployed soon. The main part of this demo covers how all these models are used in the driver app to provide best location and inventory recommendations for truck drivers. The application is designed based on a three-tier architecture consisting of a persistence layer, processing layer, and user interface layer. The persistence layer is built with Snowflake, and an API has been developed to facilitate communication between the application and Snowflake, utilizing SQL API, serverless, Flask, and AWS Lambdas. The user interface layer is developed using React Native Framework. Most applications today have become data intensive, but building successful data applications is hard, especially as the number of users and volume and complexity of the data increases. With traditional architectures, product teams fail to meet their performance KPIs and often over-provision to match variable demand. Building data pipelines is complex. You need expensive engineering team with specialized skills, and operational burden and technical debt becomes excessive. Snowflake is designed to increase engineering velocity and delivers high performance and scalability for applications. Snowflake automatically handles provisioning, availability, tuning, data protection, and other day-to-day operations so that you can focus on innovating your own app. Snowflake powers hundreds of data apps, helps software team increases engineering velocity, and delivers scalable applications without operational burden. Also, Snowflake made integration of machine learning models into the data applications easy by offering a functionality to deploy ML models as stored procedures, user-defined functions, and user-defined table functions. In the later part of my demo, you will also see how this Tasty Bytes driver app is leveraging the data from ML model and displaying on the UI for truck drivers. The ecosystem surrounding Snowflake is robust with connectors and drivers from Python, Spark, Kafka, Node.js, .NET, Golang, JDBC, and ODBC. Snowflake queries are all based on SQL, which most engineers know and like using. With separation of compute and storage in Snowflake, we can leverage cloud providers' object stores, which are affordable and highly durable. Our proprietary format automatically compresses all data to reduce costs. Snowflake provides quick and easy scaling both vertically with larger warehouses and horizontally with multi-cluster warehouses. The Tasty Bytes driver app is running in a multi-cluster warehouse. We have two modes for multi-cluster warehouse. Maximized mode is enabled by specifying the same value for both maximum and minimum number of clusters. In this mode, when the warehouse is started, Snowflake starts all the clusters so that maximum resources are available while the warehouse is running. This mode is effective for statistically controlling the available compute resources, particularly if you have a large number of concurrent user sessions under queries. The numbers do not fluctuate significantly. Another mode is autoscale, which we are using. This mode is enabled by specifying different values for maximum and minimum number of clusters. In this mode, Snowflake starts and stops clusters as needed to dynamically manage the load on the warehouse. As the number of concurrent user sessions under queries for the warehouse increases and queries start to queue due to insufficient resources, Snowflake automatically starts additional clusters up to maximum number defined for the warehouse. Similarly, as load on the warehouse decreases, Snowflake automatically shuts down clusters to reduce the number of running clusters and correspondingly the number of credits used by the warehouse. For the driver app, we expect more load from truck drivers during shift timings, which are from morning 9 a.m. to midnight. So that's why we are using auto scale mode, which automatically manages the clusters. Performance is optimized with multiple levels of caching. metadata, which contains all micro-partition information, is cached, so clusters can quickly find the data they need. Micro-partitions are again cached on the clusters to limit latency from pulling data out of object storage. Query results are also cached to short-circuit subsequent identical queries. These layers of caching allow Snowflake to store large data sets affordably and still offer amazing performance. Applications often have use cases where more data could be leveraged from partners or the marketplace to enrich data and provide more insights. Snowflake data sharing allows for easy consumption sharing of data between partners and our customers. This ecosystem provides up-to-date datasets without the need to export or share data manually, which is immediately stale and requires the receiver to load before use. In the later part of my demo, I'll show you how we are leveraging Snowflake Marketplace data in the application. To accelerate the data apps development, Snowflake also provides a SQL API, which is a REST API that you can use to access and update data in Snowflake database. In our demo, I have created a custom API endpoints using Flask, which uses SQL API to fetch the data. You can also use SQL API directly to access the data from Snowflake. SQL API supports OAuth and key pair authentication to authenticate with Snowflake. In this demo, we are using key pair authentication by generating JWT token. Snowflake Docs has clear instructions on the fields that needs to be in the payload to be used to generate the JWT token. I'll also go through it in a bit. The docs also has sample examples on how to generate the token from multiple programming languages as well. SQL API also supports querying stored procedures and UDFs, which is a very good feature when you have ML models deployed in Snowflake. With this, let's launch the app. This is the React Native driver app powered by Snowflake. This app is designed to function as a mobile or web application that can be run on iOS, Android, or web platforms. For the purpose of demonstration, I'm running the application in a web browser with some additional style. Now I'll log in into the app as a truck driver with credentials. I'm using truck 50. Each driver is associated with a truck, and I'm using truck 50, which is located in Boston. Once I'm logged in as a truck driver, I'm provided with a screen which shows the selected location for the upcoming shift. Driver has morning and evening shifts. Morning shifts are from 9 a.m. to 3 p.m. and evening shift is from 5 p.m. to midnight. A driver can select different locations for each shift. They can also pre-select the locations they would be serving a week before. I would go through that process in the later part of my demo. So this screen helps truck driver to see the location details like address, the time they need to be there, the location by, and also forecast of shift sets. This prediction is coming from Location Recommendation ML model, which is also deployed in Snowflake. From this screen, driver also has an option to change the location, view the checklist of inventory they need to serve this location. Also, navigation helps the driver to navigate to that particular location. Now let's see how Snowflake is powering this page and how we are accessing data from Snowflake and displaying it in the app. While loading this page, I had my developer tools open to show you the outgoing network calls. As you can see in my network tab, there is a get API call to fetch the selected location details you're seeing on the screen. This is a Flask API endpoint which expects truck ID, shift, and date to be passed as the query parameters. Now let's take a look at the preview of the data that we are getting from Snowflake, which gives the location name, mass, historical, and all that. Now let's see how this call is initiated from React Native. I have my Visual Studio Code open with my front-end source code in it. This code is also available in our Frostbite team GitHub repo. The README file has all the instructions on how to run the app locally, or you can use the pre-deployed app instance as well to play around. So this location details file has the code to render this location details screen. At the page load, we are calling this function getLocationDetails, which fires the API call to endpoint named getSelectedLocationDetails. We are passing logged in truck ID, current shift, which expects 0 or 1. 0 is for morning shift and 1 is for evening shift. This is calculated based on the shift timings. If the current time is before 3 p.m., then we show morning shift information, and after 3 p.m. is considered as evening shift. You would also need to pass date to filter the selected location for a particular truck, date, and a shift. Once the API call is completed and response is received, we are storing the response in a React state variable called location details. And we are using this variable to display the content on the UI using React Native views. Now let's see how this endpoint is defined and how this is fetching data from Snowflake. This is my backend Flask API source code. Our GitHub repo has instructions on how to run this locally as well. So this get selected location details is the endpoint we were using, and these are the arguments it is expecting: truck ID, shift, and date. And this is a SQL query which gets submitted behind the scenes. This query has columns that we need, like forecast, date, location ID, country, shift forecast, city, address, and all that, which is coming from app truck shifts view. And we are also joining this with location details view to get the latitude, longitude, and additional details. And these views are sitting in our analytics layer. If you want to know more about how we manage raw data, harmonized and analytic views, or for any other data engineering best practices, please use our GitHub repo, which has all the details. We also have a couple of quick starts available from our team, which would be really helpful. And we are also applying the filters for truck ID, forecast, date, and shift to narrow down to a particular shift and a date, and for a particular truck. So now we're calling this execute and fetch method, which is firing a HTTP call using SQL API. This SQL API URL is nothing but your Snowflake account.snowflakecomputing.com. And they have clear instructions in the Snowflake docs as well. And this is the endpoint that we're using to get the data. It expects JSON body and the headers. So the JSON body is nothing but your SQL query, which expects in a format. And your SQL query statement is nothing but the SQL query. And you can provide the timeout and other parameters like the database, schema, and warehouse you're accessing it from. And this query type is optional, which you can pass. And this is passed as a body to this REST API call. And headers are authorization header, content types, Snowflake account. And since we're using key pair authentication, we are saying token type as key pair JWT. And for the authorization, you need a bearer token. And this bearer token we are generating, all the source code for this are available in this file. We also have instructions in our Snowflake docs on how to generate this and what payload needs to be passed. So here, to generate the JWT token, you need Snowflake account, user, and the private key, which are defined in my serverless YAML file. And we also need to provide the database schema and warehouse information. A private key is hidden for the security reasons. Once a token is generated, we need to pass that as one of the authorization headers to this REST API call. And once we receive the response from Snowflake, it's passed back to the UI layer. This is how we use the SQL API to get the data from Snowflake. You can also use the Python connector, which is similar to what we have done for SQL API. You need to pass the user account and warehouse information to the Python connector. We have examples of both using SQL API and Python connector in our GitHub repo, which you can refer it as well. Now let's take a look at the API call that we sent to Snowflake. This is my query history. This is the API call that we just fired, which submitted the SQL statement with forecast, date, truck ID, and shift information. You can also see the additional information like duration, query tag that we passed and stuff. And also there's an option for query profile, which you can click on it and see it as well. Now let's go back to the app. We have an option for truck driver to change the location. Once I click on change location button, I'm provided with a screen which shows the location recommendations ordered by predictor shift sales. These recommendations are coming from an ML model, which is deployed in Snowflake as a UDF, and we're using a view to get the recommendations. You could also query the UDF directly if you want. This ML model is built using Snowpark, which makes it easy for Python users to leverage Snowflake platform. This model uses Safegraph weather dataset from Snowflake Data Marketplace to provide more information to the model. This improves model performance. If you're interested to know more about how this model is built, please look into our Snowpark 101 notebook from Data Science Vignette. Now let's see how this page is developed. This page uses file locations.js, which calls function getLocations from UDF on the page load, which fires an API call to get location recommendations, passing truck ID, shift, and date. Let's take a look at the definition of this endpoint. So this is an endpoint which is getting the location recommendations. And as you can see, we are querying this app location recommendation view and passing city, menu type, day of week you need, the prediction for shift, etc. So here I have a view which is created on top of the UDF, and we are querying that view. You can also directly query the UDF as well. Now let's see how this UDF is deployed in Snowflake. We can find the deployed UDF under analytics functions, and the UDF is UDF predict location sales. Now let's say I change my mind and I want to go to a different location for the next shift. And let's say if I want to go to Reservation Road Park, I can just click on accept, which updates the selected location back in Snowflake. And you can see that predictor shift sales changed for this particular location. And once you change the location, you can also see the checklist for the location. This screen shows the inventory needed to serve a particular location. This recommendation is coming from the inventory forecast machine learning model, which is again built using Snowpark. This model provides the prediction menu item quantity at each location for upcoming shifts. This model is also deployed as an UDF for app and analytics teams to use it. Based on this prediction, driver now can decide whether he can serve the location or not. And here you can see all these green boxes means he has all the inventory that he needed to serve this location. And if you're seeing any reds, that means you don't have the inventory that you needed. Truck gets new stock every Monday, so we might not be seeing any reds until end of the week, or we might not if the orders are expected as per the prediction. Now that he has all the inventory that he needed, next step is for him to navigate to that location. So this navigate button helps him navigate from the warehouse to the location that he has selected, and which shows the estimate of how long he would need to go to that location as well. Once he's at the location and ready, he can click on I'm ready button, which makes the ordering system active. This is the order screen. Once the orders are placed, those will start coming up in the in-queue tab. We are using React Native flat list to render this list view. Driver also has an option to see the order by clicking on View Order button from here. This order details screen has the information of the quantity and the menu items that was ordered by the customer, and also the order amount and discounts if any were applied. This order details page is powering the screen, and once the order is delivered to the customer, driver can click on Order Ready button, which updates the order status back in Snowflake using this Update Order Details endpoint. And this in-queue screen gets updated, and if you want to see the orders that were completed, you can click on Order History tab, which gets the latest orders that were completed. Driver has an option to see view order from here as well. He can just click on view order and see the order details. Now let's go back. Driver also has an option to see notifications in the app from Notifications tab. Here, driver can see current day's reviews if provided any. This review data is coming from Iceberg tables. We are using Iceberg tables since this data is powered by multiple sources from outside with different file formats. While Snowflake's internal tables greatly simplify the process of creating a data lake, mesh, or other storage patterns for data stored directly in Snowflake, some organizations with regulatory or other constraints either are not able to store all of their data in Snowflake or prefer to store data in open formats. Iceberg tables combine the performance and familiar query semantics of Snowflake tables, and these are currently in private preview by the Snowflake Data Cloud. We also have a Streamlit app where you can submit the reviews, and this is again stored in Iceberg tables. All the survey data is used by our voice of customer machine learning model to analyze the customer sentiment by providing Net Promoter Score to benchmark customer satisfaction. And this Net Promoter Score is provided in 3 different categories. promoters, passives, detractors. This enables Tasty Bytes organization to better understand the areas which require improvement and drive up customer loyalty along with satisfaction. Also, querying the Iceberg tables and showing the data is almost similar to regular tables. We're using this data app survey data view to get the data from Iceberg tables and displaying it in the app. We're also joining this with the customer loyalty. We have a loyalty customers, and if any of the surveys are provided by the loyalty customers, we get their details, image, and display it here. From here, driver also has an option to see the review by clicking on the See Review button, which provides a detailed overview on the review. And driver can learn where it went wrong with food or service, etc. And if there are any comments provided, that will get displayed here as well. Drivers also will be notified if there are any ingredients expiring soon and needs to be used right away. With this data, driver may be able to run any specials or discounts. From here, they can click on View Inventory and see the current inventory on the truck with all the expiration dates. For example, you can expand the record and see the details of each item expiring on which date. Profile screen gives the driver an overview of number of locations he has visited, his overall rating, and current day's earnings and total earnings. Driver also has an option to navigate to the reviews, food waste, inventory, and menu screens. Let's take a detailed look at the earnings. Earnings shares file is powering this page, and at the page load time, you can see that we are firing an endpoint call to get driver earnings. Here you can see each shift earnings for a truck with location details ordered by date and total earned so far and the total number of unique locations that the driver has visited. You can also click on earnings record to see the details of the inventory sold at this particular location. This data is coming from the order history based on number of items we sold in that particular shift. This data is again used by ML models to predict the inventory forecast for the upcoming shifts. Now let's go back to the profile page and take a look at the review screen. This review screen shows rating count, number of reviews that were provided for the truck driver, and all the reviews ordered by date. The latest reviews that were provided are the anonymous customers. If any of these customers are part of the customer loyalty, you can see their details and image here. For example, you can click on full review button to see the full review details, like how much the customer has rated for food, service, price, etc. And also if there were any comments that were provided. We plan to include an option for driver to be able to respond back to the review from here, which can then again used for sentiment analysis. Now let's go back to food waste screen. This screen shows the food wasted in each month and also percentage of wasted inventory to total ordered inventory ratio so that driver can review the percentage of food is being wasted. For this demo, we have partnered with DBT Labs for data transformation. DBT support data transformation and orchestration at scale, in our case, taking various raw source system tables, harmonizing them, and deploying easy-to-digest analytical views like we use for this food waste screen. And this is the lineage of how this item wastage view is getting created, considering distribution summary, stock assignments, and the supply chain items. This food item wastage gets calculated considering the items that were ordered, the items that were used, and the food that is getting expired before it gets used. From here, driver can click on this button and see the inventory being wasted, which will give the driver an idea of the items that are being wasted more. Now let's go back to the profile page and take a look at the menu screen. Driver can see the truck menu. We are coming up with a price elasticity model soon. With this, driver can see the model recommendation for price of the menu item, which could boost the earnings. They'll have an option here in the app to update the price based on the model recommendations. Currently, this page is using get menu items endpoint to get the details of the menu item and the price, and we're using React Native flat list to render this page. Now let's take a look at the inventory. This screen shows the current inventory on truck with expiration dates. The current inventory on the truck is calculated based on the inventory ordered minus inventory sold based on the orders data that we have. Sometimes he might be using little more or sometimes he might be using little less. So he has an option to update the inventory that he has on the truck. For example, he can change the inventory and hit save, which updates the data back in Snowflake. And you can see that it got reflected here. And it is fairly fast to update the Snowflake tables, and we can reevaluate this again once Snowflake hybrid tables are available. Now let's take a look at how this page is rendering. This page uses current inventory file, which fires an API call to get the current inventory at the page load time. And once the user clicks on the expand button, this get item inventory endpoints gets called to get the items and the expiration dates for each item. Also here, when driver updates any of the records, we have an endpoint to submit the update query to Snowflake, which takes updated data as input. You can actually update multiple records at once, which submits the multiple update queries back to the Snowflake. From here, driver also has an option to order for next week by clicking on this order for next week button. Our inventory schedules are from Monday to Sunday, and every Sunday truck gets new inventory. For the driver to order the inventory for next week, he needs to select the locations that he would want to visit for each shift next week. If he doesn't select the locations, app selects one of the model recommendations for him. So driver can expand each day and shift and can see the location that was suggested. He can use the same one or change it by clicking on the change button here, which gives him the location recommendations for that given day and a shift. This is again coming from the location recommendations machine learning model, which forecasts the shift sales, and we are ordering it by shift sales and displaying it here. He can accept one of the locations. If he would like to change the previous one, for example, if he wants to go to this one, he can hit accept, and he can save an order, which saves the selected location back in database and also gets the inventory forecast for next week based on the locations that he has just selected in the previous screen. This screen provides additional inventory needed for next week to serve all the locations that he has selected. And this uses inventory order page, which is using get inventory order endpoint. This data is again coming from inventory forecast machine learning model, which is deployed as an UDF within Snowflake. We're using a view to query the UDF and display the information on the UI. The main goal of the Tasty Bytes organization is to minimize the losses in sales due to missing inventory and reduce food waste from unused inventory. This model takes historical menu item sales at each location, which is available in Snowflake, and also Safegraph weather data from Marketplace as one of the features, and provides the predicted menu item quantity at each location for all the upcoming shifts. This will improve the sales and minimizes the food waste. This forecast output from model helps the driver to order the right quantities for the next week. He can also update the quantities if he would like any additional quantities for any of the ingredients. For example, if he wants to update the quantity, he can just update it from here and hit place order. Once he clicks on place order, a purchase order would get generated and order details are stored in Snowflake. You can see the order summary and expected delivery date from here. This is the overall app flow. We have the source code for this available in our GitHub repo, and a quick start is on the way. We have documentation and many quick starts available on Snowflake website for you to get started. Thanks for watching.